Okay. Good afternoon, everyone. I'm very honored to be here with you today. And my topic is how to deploy 800 nodes in 8 hours automatically. I guess you may have many questions when you are hearing this topic for the first time. Why did you deploy so many nodes? How did you make it in 8 hours? What problems did you have? And how did you resolve them? I'm sure you are going to get the answers. But before that, please allow me to introduce myself and my company briefly. My name is Chen Tao. I have been working for over 9 years in networking and software fields. Currently, I'm working in T2 Cloud as a senior engineer. T2 Cloud is a rapidly growing company in China, which focuses on cloud computing. We are the leading cloud solution provider in China. We have over 100 employees, and 80% are OpenStack-related engineers. The core team have already been committing to OpenStack for many years, ever since the release access. We are a member of OpenStack Foundation and have always been promoting OpenStack in China. We have ever built the first open source cloud in media industry and data center in China. Especially, we have built the largest scale of OpenStack environment in transportation industry in China. We have many productions such as T2 Cloud OS and Medic Stack. T2 Cloud stands for Transform to Cloud, and our goal is to help China's enterprises to transform from old IT infrastructure to new cloud services supported by OpenStack. My topic is divided into 4 parts. First of all, I will have an overview of the project with you so that you can know what the project looks like. Then I will show you the DevOps platform that we use to do the automated deployment. After that, we will focus on details of the automated deployment process. And finally, I will give you some suggestions if you are going to deploy a big cluster of OpenStack environment. All right, let's get started. Why did you deploy 800 nodes, and especially in just one region? To answer the question, I have to introduce one of our partners. That is China Railway Corporation. Rail transportation is one of the most important long-distance transportation in China. By 2015, China has over 120,000 kilometers of railways, the second longest network in the world. As you can see from the picture, Spring Festival travel rush creates the world's largest annual human migration every year. Almost all rail operations are handled by the China Railway Corporation, a state-owned enterprise, which is also the only one railway enterprise in China. By the way, China Railway Corporation has over 2 million employees, and the total assets are nearly $700 billion. With so many customers and employees that the old IT infrastructure cannot meet the requirement anymore. A new kind of IT framework is badly necessary to China Railway Corporation. And OpenStack is definitely a good choice. T2 Cloud has been collaborating with China Railway Corporation for a long time in order to build a large-scale private cloud. But before making it into reality, there's a long way to go. It's very important to verify what's the capability of one region, how many virtual machines could be created in such a region, and whether or not they could run stably. If one region is powerful enough, then we can deploy more regions, and we can confidently move more services to cloud. That's why we deployed 800 nodes in just one region. So do you have anything to say about the 8 hours? Oh, yes. The project was better urgent. Deploy OpenStack was just the first step. Much work had to be done when the environment was ready. We didn't know how many issues we would encounter after that, so it is better to finish deployment as soon as we can. Finally, we made it in less than 8 hours, saving a lot of time for our colleagues to do more tests. In this slide, you can see the physical topology of this project. As you can see, we deploy 3 controller nodes, 601 computer nodes, and 117 storage nodes. In addition to that, there are other 79 nodes working as bare metal and big data nodes. So the total number was 800. After the deployment, we created about 1,000 virtual machines, and based on that, we did a lot of tests, including scalability test, performance test, high availability test, and stability test. All of the tests lasted for 30 days, and many issues were exposed indeed. This slide shows the logical architecture of this big-scale OpenStack cluster. In the 3 controller nodes, there are KPLFD, HAProxy, RabbitMQ, MySQL, and OpenStack API servers. 3 controller nodes could provide high availability. All the other nodes talk to the master of the 3 controllers. If the master fails, one of the other 2 will become a new master. It's not so complicated for other nodes. There are some neutron agents in the network nodes. Nova computer service and neutron Linux bridge agents could be found in computer nodes. In the storage nodes, Ceph is deployed to provide a distributed storage. Just as the old saying goes, to do a good job, one must first sharpen his tools. In order to deploy and maintain OpenStack environment conveniently, we designed the DevOps platform. The DevOps platform consists of 6 subsystems. The first one is SamDB, where we could manage our assets, for example, physical servers, switches, routers, and firewalls. You can manually input them or use plugins to discover them. The assets recorded here will be used by other subsystems. The second is OS installation subsystem. You know, a complete auto-deploy process always starts from installing operating system. Manually installing OS to hundreds of nodes is definitely impossible. An automatic and efficient way of installing OS is very important. Actually, we use the IPMI tools to manage the power state and boot sequence of physical nodes, and use cobbler to do OS installation automatically. The third one is OpenStack deployment subsystem, which is the most important one to us. As we know, deploying OpenStack is a very complicated task. Even a small mistake may lead to a big disaster, and we waste much of our time. Even a skilled man cannot be careful enough when he's deploying OpenStack. Therefore, how to deploy OpenStack efficiently and accurately is a big challenge. As you can see, Ansible is used by us to do the deploying work. The next one is task management system, where you can design and run the tasks on remote nodes. It's useful for us to control and manage the remote nodes. Automation test is also included in this platform. If you get no errors in the deployment process, can you see that the environment is basically ready for use? I guess we can only see that until the result of the test is passed. The last subsystem is health check and monitoring. Just like human body check, there may be some potential problems inside the cluster. It is better to find them earlier. This subsystem will help you avoid making mistakes or help you to troubleshoot problems. It will also let you know all the status of the cluster all the time during the deployment. So the automated deployment will cover 3 subsystems. In the OS installation subsystem, I will show you how we installed OS to 800 nodes. In the OpenStack deployment subsystem, I will show you how we use Ansible to deploy OpenStack quickly and accurately. In the health check subsystem, I will show you what are checked during the whole deployment process. To do OS installation automatically, Pixie and Kickstart are usually used. Pixie is a well-known industry standard technology, and Kickstart is a configuration file for OS installation program to follow during the installation process. I will explain how it works. First, several servers must be installed and configured properly. Then you need to set a node to boot from network and reboot it. Now Pixie starts working. Pixie client is an onboard program inside the network adapter. It firstly requests an IP address so that it could communicate with the other servers. The DHCP server receives the request and responds with an IP address. It will also tell the client which bootloader to download and where to download it. Pixie client then downloads network boot program from TFTP server and runs it. After that, Pixie client downloads the kernel and RAMFS from TFTP server. When all these items are downloaded and executed, a temporary Linux system is ready and the OS installation program Anaconda is loaded. After that, Anaconda will download Kickstart and then install OS according to configurations that are specified in the Kickstart file. So I was trying to explain it briefly just now, but it still seemed to be a little complicated. And that's why we used cobbler. The main advantage of cobbler is that it glues together many disjoint technologies and concepts and abstracts user from the need to understand them. It allows the system administrator to concentrate on what he needs to do and not how it is done. So you don't have to manually configure the servers, ISO images, and Kickstart files. Cobbler will help you to do it. What's more, cobbler provides many ways to use, including command line, web UI, and APIs. That is really useful and can be used to automate the OS installation progress. You can see there are several downloading operations in the OS installation process. In order to get better performance, we divided our 800 nodes into 3 groups and prepared one cobbler server for each group. Every time, we started 20 nodes in each group, and 3 groups were started concurrently. It took about 10 minutes to finish, so we can finish 60 nodes every 10 minutes. It took us about 3 hours to finish all nodes. 2 nodes failed during the installation due to hardware issue, and we fixed them and reinstalled OS at last. Cobbler is widely used, so I don't think you will get too much trouble in using it. Yet, I have some tips for you. The first one is how to select the target disk. Suppose that we have one SSD and some other disks in each of the nodes, and we are going to install OS on the SSD. Since we have too many nodes, the SSD may be installed into different slots in different nodes, so it will be recognized differently. Maybe SDA, SDB, or SDE. But it is required to fill in a disk drive in the kickstart file, and that's the problem. The solution is to use cobbler snippet. Snippets are some pieces of scripts which will be used by Anaconda to perform specific tasks. So we just need to write scripts on how to find the disk dynamically, maybe by the capacity or disk type. Let's go to the next one. Traditionally, network interfaces in Linux are enumerated as ETH 0, 1, 2, 3, but these names do not necessarily correspond to actual labels on the chassis. In CentOS 7 and Red Hat 7, there are new schemes for network adapters. You can see the name starts with ENO instead of ETH. So if you want the old naming back, you can just tell cobbler to add kernel options, and then cobbler can do the rest for you. As I mentioned earlier, we use Ansible to deploy OpenStack. So why Ansible? Just as described in Ansible's website, Ansible has a number of qualities that makes it the most rapidly growing automation platform in the world. First, it is extraordinarily simple. Playbooks are human and machine readable, so no special coding skills are required. Even when one doesn't know what Ansible is, he can likely read a playbook and understand what's happening. This simplicity means you can start using Ansible to do real work with it in just minutes. Ansible also works like what you think. Tasks are always executed in order. Altogether, the simplicity ensures you can start quickly. Now, simplicity is great, but to be really useful, you also need some powerful features that can ensure you can control even the most complex IT flow works. So what can Ansible do? Nearly anything. It can manage the infrastructure, networks, operating systems, and services that you are already using today. Finally, Ansible is completely agentless. It relies on industry standard and trusted SSH protocol to automate. There are no agents or other softwares installed on the system where you are automating on. Now I will show you how we use Ansible in our environment. There are mainly two ways to use Ansible: ad hoc and playbook. An ad hoc command is something that you might type in to do something really quick, but do not want to save for later. For example, if we want to install a software on all the remote machines, we just need to execute one-line command. Compared with ad hoc, playbook is a completely different way to use Ansible, and is particularly powerful. To use Ansible, we need a few things. Inventories. Inventories are essentially lists of hosts. In our environment, we divided our 800 nodes into 4 lists. That is controller, computer, network, and storage. Row. A row is a collection of tasks and related files. We treat each OpenStack component as a row. The steps on how to deploy an OpenStack component are described in the tasks. Tasks call modules to do real work, and there are over 1,000 modules provided by Ansible. One thing I have to mention is that almost all modules that we used are idempotent. What does that mean? For example, if we want to copy a file to the remote machine, the module will check if the file is already there. If so, it will return OK and do nothing. Idempotent means you can run a module many times and get the same result. Group-wise, it is where you can define variables for the groups. Remember, there is a default group named all. Variables defined in the group all can be treated as global variables. Host-wise, it is where you can define variables for particular hosts. It is very useful when the configuration of one node is different from most of the others. For example, if node A has 3 disks, while all the others have 2 disks, then you can write a YAML file for node A and put the difference into it. Library. It is where you can put your own modules. Ansible supports self-defined modules. The modules here will be loaded automatically. The 4 YAML files are plays. Each play describes the relationship between hosts and their rows. We divided the deployment into 4 sections: safe, controller, computer, and network. So we just need to run the 4 playbooks one by one to do OpenStack deployment. As mentioned earlier, Ansible uses SSH to make connections to the remote nodes. Therefore, Ansible may work not so fast, but there's something that we can do to improve the execution speed of Ansible. The first one is to disable gathering fact function. When the playbook runs, the first thing is always to run the setup step. In this step, Ansible tries to collect as much information as possible from the remote nodes. It's a default behavior. However, it is unnecessary sometimes. By disabling this, we can save a lot of time. Second one is to enable SSH pipeline. SSH pipeline is an Ansible feature to reduce the number of connections to a host. Ansible will normally create a temporary directory in the remote system, and then for each task, copy the module source to the directory and execute the module. So there are at least 3 connections for each module. With pipeline enabled, Ansible will connect only once per task. Be careful to use this because it may be incompatible with sudo command. The third one is to increase the number of forks. The default value is 5, and that is definitely insufficient. So please don't hesitate to modify it. The last one is to upgrade SSH to the latest version and enable control persist. By enabling control persist, when you stop an SSH session to a node, the connection is in fact not destroyed until time is out. So you can use it directly next time when you connect to the node. By doing the 4 steps, I think your Ansible would run faster in large-scale environment. It is the first time for us to deploy such a big cluster. The OpenStack deployment process was not so smooth. It took us more than 4 hours to finish, much longer than the time we usually use to deploy small clusters. There were many issues found during the OpenStack deployment process, and some of which we had never encountered before. So I will show you some of the issues. The first one, when we finished installing network nodes and used neutron agent list to get the agent status, the result showed that over 400 neutron agents were down. There were some possibilities for such problems. We know neutron agents report their status periodically to neutron server via message queue. If neutron server receives the report, it will compare the report time with the last one. If the time difference is not bigger than default value, then the agent will be marked as up. So the problem is, were the report messages sent successfully? Did neutron server receive the message? And were the messages handled successfully? After we checked neutron agent's log and found that they could not connect to RabbitMQ. From RabbitMQ's log, we found that it had run out of file descriptors. The default number of file descriptor was 1024. It is insufficient, and the solution is to increase the number of file descriptor for the system and for RabbitMQ server. The next issue is that Cinder service failed to start during the deployment. From Cinder's API log, we found the error message. Cinder already has more than max user connection active connections. Both Cinder API and Cinder volumes need to connect to database. And one Cinder volume service may establish many connections to database, while the default connection number of MySQL was limited to 1,000. That was insufficient. And so the solution is to increase the maximum connection number for MySQL. Actually, we found a lot of items to optimize during the deployment process and the test process. Maybe it is useful for you. So health check and monitoring are very important to us. They work all the time. Before deployment, it helps us to check the following items. Is virtualization enabled in computer nodes? Are all the network adapters working? All the disks recognized correctly, and is time synchronized among the nodes? And during the deployment process, it helps to report platforms and send notifications to us automatically. So it is not necessary for us to sit in front of the computer and stare at the screen. After the deployment, health check can do a lot for us. It scans services in the modules. And scans for errors in the logs. What is more, it helps us to check the state of clusters. For example, the MariaDB cluster, RabbitMQ cluster, and MongoDB cluster. It is particularly useful when there's something wrong with the cluster. You can just run health check and know what is probably going wrong. Sorry, there's something wrong with the project. Okay, thank you. In the end, I want to give you some suggestions if you are going to deploy a big cluster of OpenStack environment. First one is you have to do more tests to find the bottleneck of the cluster. It is suggested that you always do health check to avoid making mistakes. It is great if you can deploy OpenStack quickly, but it is more important that you can make your cloud stable. So that is all that's all for my presentation. Thank you. So if you have any question, you can feel free to ask.
How do you deal with registering that many servers in cobbler? Are you pre-populating it somehow, importing it from some sort of spreadsheet, or do you have some sort of discovery engine that you use? How do you get the systems into cobbler?
we can use nmap to discover them automatically. Also, they can be imported from a data sheet.
So you guys have a sheet that just has all the MAC addresses, and then you can build the system profiles from that?
Yes. So any other questions?
So what was the reason you wrote your own Ansible scripts for the OpenStack deployment? Why aren't you using something from upstream, for example, OpenStack Ansible?
Sorry, I didn't.
Why not use Cola or OpenStack Ansible? Why did you write your own?
You mean Cola Ansible?
Yeah.
Cola Ansible is another project that we have started recently.
So you wrote yours before they were out?
One thing I forgot to tell you is that we deployed release L in this project, and we are going to deploy the release O using Cola Ansible. Okay, no more questions. Okay. Sorry, I didn't. Oh, okay. I will show you the slides. Okay, thank you. Thank you all.